Here we're looking at vector subtraction, but in context. So we have an aeroplane that needs to fly due east from one city to another at a speed of 400 kilometers per hour. However, a 50 kilometer hour wind blows constantly from the northeast. So the plane wants to go in an easterly direction. So the plane wants to go east. However, we have a wind blowing at 50 kilometers per hour from the northeast. So the wind's coming across like this. So it's blowing it at 50 kilometers per hour. So that means that's going to take the plane off course. It's going to be flying down here. So what we have to do is we have to decide where the plane's going to go so the wind doesn't take it off course. So theoretically, the plane would have to fly out here, out in that direction. So it can actually have that desired outcome of going due east. Because if it flies east, the wind is going to take it off course. So what we're going to have is a vector. So this is where we want it to go. So this is where we want the plane to go. But we have the wind. The wind is going this way, northeast, from the northeasterly direction. So we want to do we need to have we need a negative vector of that. So that's the same magnitude but a different direction. So we have the negative wind. So negative W. And this is where we want the plane to be flying. So this is the flight. That's the plane. And we have the negative wind there. And from there, we can find out what we want the plane to be doing. Because we want it to be going 400 kilometers per hour east, and with the wind of 50, we need to find now what it actually should be doing. It's what we want it to be doing, 400 kilometers per hour east, but what we want it to be doing. So we use the cosine rule. Before we go, we need to know what this angle is here. Move on. So that angle here at angle B, well, it's 90 degrees plus the 45 degrees that the northeasterly wind is. That's 45 degrees, so it's halfway between north and east. That's 90 degrees is north and east, so northeast is 45. So that angle there is going to be 135 degrees. So from there, we can find out what P is, what the plane will actually be doing. So that's B squared equals 50 squared, because that's the wind, plus the ideal 400 per hour squared that we want it to be doing, minus 2 times 50 times 400 times cos 135. That equals, so B will equal, because we'll have to square root that, we'll get 436.8 kilometers per hour. And that makes sense that the plane will actually have to travel faster than 400 kilometers an hour, because the northeasterly is sort of like a headwind. It's sort of going to be slowing it down and taking it off course. So now that we've got B, how fast the plane will be going, we can now find in what direction, and that's going to be theta. So that's the bearing there at angle A. So we're going to have sine theta over 50 equals sine 135 over 436.8. That's obviously using the sine rule. So theta is going to be 4.6 degrees. So this plane will be flying 436.8 kilometers per hour. 4.6 degrees north of east. Now, you could either do it that way, or you could write the bearing as, well, it's going to be less than 90 degrees because east is 9 degrees. It could be a heading of, well, 90 take 4.6 is 85.4 degrees. So it could be either on a heading of 85.4 degrees. That could be just its bearing in general. So either one of these answers is fine.